Alright, geometry students, so today we are moving into our new unit all about parallel and perpendicular lines. So today we're going to start with parallel lines, and to be successful with this lesson, we should be able to compare angle relationships when parallel lines are cut by what's called a transversal. And so just to recap what's going to be in our lesson, we are going to be defining parallel lines and what transversals are. We're going to talk about the angles formed by transversals, and then we will talk about the special angle relationships that are formed when parallel lines are cut by a transversal. You'll want to have your guided notes to go along with this lesson. Let's get started. So let's talk about parallel lines, and this part should be review for us. So parallel lines are two or more coplanar lines. That means two lines that are on the same plane as each other, and those lines never intersect. Parallel lines are two coplanar lines that never intersect. Arrows are used to indicate the lines are parallel. So let me highlight what those look like. So that's these arrows here. And that shows that line AB is parallel to line CD. So that would look like this. Line AB, with the line notation over it, is parallel to CD. So the two lines, they just look like parallel lines, really. That's the symbol notation, like that. Now let's talk about transversals. Transversals are lines that intersect two or more lines. So in the diagram shown, line T is intersecting both line L and line M. So line T would be a transversal line. It transverses both lines. Now let's talk about angles that are formed by a transversal. Again, in this diagram, we are seeing that line T is the transversal line. It intersects both lines L and line M. And when that happens, 8 angles are formed. So you've got 1 through 8 angles here. So let's talk about those relationships. The first kind is called corresponding angles. And these are angles that are on the same side of the transversal and in the same position. So I'm seeing quite a few. So if I look at these angles kind of like quads, I see quad with angles 1 through 4, and I see a quad with angles 5 through 8. I see that angles 1 and angle 5 are in the top left quadrant, I guess you can say. They're in the same position as each other. So I would say that angle 1 and angle 5 are a pair of corresponding angles. And we can go clockwise doing the same thing. Angle 2 and angle 6 are in the top right quadrant. They are corresponding to each other. And that's the same with angles 3 and angle 7, and angle 4 and angle 8. Angle 3 and angle 7, and angle 4 and angle 8. Now let's talk about alternate interior angles. These are interior angles, meaning they're inside lines L and M here. They're between these lines. Interior angles. They are not next to each other, and they are on opposite sides of the transversal. Alternate is just another way to say opposite. So if I look at the angles that are on opposite sides of the transversal, let me erase some things here. If I look at angles that are on opposite sides of the transversal, I see two groups. I see 1, 4, 5, and 8, And then on the other side, I see 2, 3, 6, and 7. And so now I'm looking at the angles that are on opposite sides and inside the lines. So that would be angles 4 and 6 and angles 3 and 5. Angle 4 and angle 6. And then angle 3 and angle 5. Now we're looking at alternate exterior angles. These are angles that are outside of the two lines that are being intersected. They're outside, they're not next to each other, and they're on opposite sides of the transversal. So if I look at exterior angles, I am seeing angles 1 and 2 and angles 7 and 8. Those are exterior. Now they're opposite pairs, the pairs that are opposite sides of the transversal line, line T, that would be angle 1 and angle 7. Angle 1 and angle 7. And then my other pair would be angle 2 and angle 8. Angle 2 and angle 8. Next we have consecutive or same side interior angles. These are inside lines L and M. They are interior, and they are on the same side of the transversal. So when I see the angles inside lines L and M, I see 4, 5, 3, and 6. And I want to find the pairs that are on the same side of line T. So 4 and 5 are on the same side, and they're inside the intersected lines. So angles 4 and angle 5. Let me switch up my colors again. Angles 4 and 5. And then on the other side would be angles 3 and 6. These are same side interior angles. And we have consecutive or same side exterior angles. These are outside of lines L and M, or outside the lines that are intersected, and they're on the same side of the transversal. So the angles that I see that are outside the intersected lines would be angles 1, 2, 8, and 7. And if I want to find the pairs that are on the same side of the transversal as each other, that would be angle 1 and 8. And we also have angle 2 and angle 7. There you go. Those are our many different types of pairs of angles formed by a transversal. So let's practice defining those relationships. So we're going to name the type of angle relationship, and if no relationships exist, we're just going to write none. So let's look at the relationship between angles 1 and 8. So angle 1 and 8. I see that well, first let's define what's our transversal, and I'm going to highlight it. And when I highlight it, line R is the transversal because it intersects two lines. It intersects lines P and Q. So now let's look at the relationship between angle 1 and angle 8. I see that they are outside of the intersected lines, outside of lines P and Q, and they're on opposite sides of the transversal. That means they are alternate, because opposite sides of the transversal, and they are exterior, outside of the intersected lines. Alternate exterior angles. Now angles 2 and 3. I notice they're on the same side as each other. Or you can also call them consecutive. They're same side and they're inside lines P and Q. That means that they are interior. So in total, that would be same side interior angles. Now looking at angles 5 and 7, I see that they're not both inside or outside the intersected lines. But I am seeing that they're in the same position as each other. Remember when we took a look at the quadrants, I guess is a way to say it, when two lines are intersected by a transversal? Angle 5 and angle 7 are both in the bottom left position. So we would call those corresponding angles. Angles 2 and 7, I see that they're inside the intersected lines, so they're interior, and I notice they're on opposite sides of line R, our transversal line. So since they're opposite sides, that would be alternate. And they are inside the intersected line, so we're going to say interior. These are alternate interior angles. Now angles 1 and angles 3. One of them is outside the lines, one of them is inside. But they are in the same position. They're in the top left quadrant of those angles formed. So those would also be corresponding angles. And we also have angles 5 and 8. 5 and 8 are on the same side of the transversal, so same side, but they are outside the intersected lines. So we're going to call these same side exterior angles. All right, now let's look at parallel lines. When parallel lines are cut by a transversal, a lot of pretty interesting things happen here. So we have a diagram shown, and I've got angles 1 through 8 again. Notice that we have two lines that are parallel based on these arrows. So when two parallel lines are cut by a transversal line, that means that corresponding angles are congruent. They are congruent to each other. So for example, angles 1 and 5 are corresponding angles. They are congruent to each other. They're both acute angles. You have linear pairs next to them. They're both congruent to each other. Alternate interior angles would also be congruent. For example, angles 4 and 6 are both alternate interior angles. They will be congruent to each other. If we assign a value, they will have the same value. Alternate exterior angles, for example, angles 2 and 8, those are also congruent. Okay, and let's talk about our same side angles. Same side interior angles, like angles 4 and 5. Notice how angle 4 is obtuse and angle 5 is acute. Well, when you add them together, they're actually going to be supplementary. They're going to add to 180 degrees. And the same goes for same side exterior angles, like angles 2 and 7. Angle 2 you'll notice is obtuse. Angle 7 is acute. This won't always be so obvious, but angles 2 and 7 will always be supplementary. This is always the relationship between these specific pairs of angles when two parallel lines are cut by a transversal. We also want to remember from a previous lesson that vertical angles, for example, angles 2 and 4 that are across from each other when two lines intersect, those are always congruent. And angles that form a linear pair, for example, angles 5 and 6, they're on the same line, adjacent to each other, those are always supplementary. So lots of angle relationships to remember when two parallel lines are cut by a transversal. So let's try this out. Let's do an example. So we're going to identify the angle pair as congruent or supplementary and give our reasoning. So if we look at A, angles 3 and 5. Angles 3 and 5. I notice that they are alternate interior angles because they're inside the parallel lines and they are on opposite sides of the transversal. That means they're congruent, and I'm just going to save some space and write the congruent symbol. And the reason I know that they are congruent is because they're alternate interior angles. Okay, B, angle 1 and angle 8. They're on the same side of the transversal. They are same side, and they are exterior, outside the parallel lines. That means they are supplementary to each other. Again, abbreviating here, supplementary. That means their measures add up to 180 degrees, and again, they are same side, exterior. Let's do one more, angle 2 and angle 6. I see that angle 2 and angle 6 are in different, angle 2 is outside the parallel lines and angle 6 is inside, but they're in the same position. If you took the first quad of angles and shifted them downward, angle 2 and angle 6 are in the same spot. So angle 2 and angle 6 are congruent because they are corresponding angles. So go ahead and practice D through H, and then if you'd like some additional practice, examples 2 and 3 provide a lot of practice with determining whether angle pairs are congruent or supplementary to each other. Let's try one more example. This one's a little bit more complicated. So if we are given the measure of angle 12 is 121 degrees. I'm going to label that right now. And we're also given the measure of angle 6 is 75 degrees. We need to find each measure. So we're going to have to work from both ends of this diagram here. I want to start out by noting that I've got two parallel lines. And what I'm seeing here is I'm seeing that angle 6 and angle 10, angle 6 and angle 10 are supplementary to each other because they are they are same side interior angles. They are supplementary. So that means that the measure of angle 10 is going to be 180 minus 75. That's 105 degrees, and I'll label it here. So now that I know the measure of angle 10, I can go ahead and also say a few things. I know that angle 9 is going to be supplementary to angle 10 because it's a linear pair. So 180 minus 105 would be 75. I know angle 9 is 75 degrees. It's going to get a little crowded in here. I know that angle 9 and angle 14 are vertical angles, which means that angle 14 is 75 degrees. I know that angle 13 and angle 10 are vertical angles, so angle 13 is 105 degrees. Let's keep going. I know that angle 12, which we were given in the start, is congruent to angle 7 because they're vertical angles. That means that angle 7 is 121 degrees. And I know that angle 11 is supplementary to either angle 7 or angle 12. They're the same measure. And that means that angle 11 is 59 degrees. 180 minus 121 is 59 degrees. Let me go ahead and label what I know here. That also means that angle 8 is 59 degrees because it is a vertical angle to angle 11. It's also forming a linear pair with angle 7. So angle 8 is 59 degrees. Okay, still labeling what I know here. Angle 4 is supplementary to angle 7 because they are same side interior angles. That means angle 4 is 59 degrees. All right, what else can we figure out here? Okay, let's figure out angle 5. Notice that angles 5, 8, and 9 form a triangle. So we know that the sum of the angles in any triangle is 180 degrees. So we take 180 minus our given angles. That's 59 degrees for angle 8 and 75 degrees for angle 9. And when you subtract those, angle 5 is going to be 46 degrees. Angle 5 is 46 degrees. And so if we know angle 5 is 46 degrees, it forms a vertical angle pair with angle 2. So that means that angle 2 is 46 degrees. They are congruent to each other. And we're almost done. We need to find out the measures of angle 1 and angle 3. And to find those measures, we're going to use the vertical angles below them. So angle 1 is directly vertical or across from angle 6. Angle 6 is 75 degrees. That means angle 1 is also 75 degrees. And angle 4 and angle 3 are vertical angles. That means that angle 3 is also 59 degrees. There you go. If you are given 1 or 2 angles in a diagram and you're given parallel lines that are cut by a transversal, you can easily find the rest of the angles in the diagram using angle relationships. For additional practice on this skill, go ahead and practice examples 4, 6, and 7. And that's it. Thank you so much for watching. Make sure you're trying out additional practice problems just to solidify your understanding of these angle relationships. Check your answers with my filled-in notes. Those are located in the content library in Topic 2 notes. And then ask for support in Math Help Desk if you need it. Thank you again for watching.